We're now going to take a really quick look at the built-in sort as well as do some timing of the different sorting algorithms that we've talked about to see which ones are empirically faster, as in which ones actually run physically faster and take less time given a list of integers. So the built-in sort, as we saw in these list operations, is just dot sort, and it'll destructively sort the list A. So we have this test function which basically takes in a sorting function, creates a big list of integers, and then we'll sort the list, get the start time, get the end time, find out how long it took, and print it out. So what we're going to do is basically say for all of the different sorting algorithms that we have, which is selection sort, bubble sort, merge sort, and the built-in sort, let's do the testing sort algorithm and see which one is fastest. So just to try and give you some intuitions on which one are faster, so selection sort and bubble sort are two of the slower algorithms because they both have to go through the list n times, and at each level, every time we go through the list, we have to do n work because we have to find the max or move the largest element to the back. Merge sort is much faster because we keep combining lists and doubling the size of the sorted list, which means that we reach a list of size n being sorted very quickly. The built-in sort is going to do an algorithm at the similar efficiency of merge sort. So let's see, we expect these two to be slower, and then merge sort and built-in sort to be at the same level. So if I run this, and actually uncomment the thing, then it'll essentially say, so selection sort took 136 milliseconds. Bubble sort took 410 milliseconds, showing that it's actually much slower than selection sort. Merge sort took 100 milliseconds, which is pretty fast, and the built-in sort took 0.01 seconds. So this is pretty crazy, right? The built-in sort did way better than merge sort, and just way better than all of them together. Now the reason this is that while the built-in sort might actually even be using merge sort, the fact is that the built-in sort is what we call compiled, as in it's built into the actual language which Python is interpreted in. What this means is that the code for the built-in sort is written in the same language that actually runs Python code. Because when Python code is written, when I write all of this code, essentially there's another language written in the programming language called C, which will take this code, see what it says, and then do what it tells it to do. However, the sorting algorithm for the built-in sort is written in C in the first place, while all the four algorithms that we write are written in Python, which means that they have to be interpreted and then run. Because the built-in sort is actually compiled in C, that means that it doesn't have to do any interpretation, and it's always going to be faster than any algorithm we could ever write. So that explains why the built-in sort is so much faster. However, it seems that selection sort isn't really that much faster than merge sort. So what we're going to do is actually increase the number of elements, because when you have more elements, it actually increases the precision with which the accuracy and speed is visualized. So if I say 2 to the 7, so in this situation, notice how selection sort actually went 4 times as slow as previously, but merge sort actually didn't increase by that much. Merge sort was before 100 milliseconds, now it's 142. Selection sort was 150, but now it's 450. So as you can see, as we increase the number of elements, merge sort is actually doing a lot better than selection sort, and bubble sort also is taking a long time, while the built-in sort being compiled is actually taking a very short amount of time. So when we talk about efficiency later on in the course, we'll be able to understand why mathematically and prove the amount of time that it takes for an algorithm to run, and thus we'll expect these things to take the amount of time that it takes, and not be surprised when one works much faster than the other.